I explained in the last video why it is that Tn, the nth term of an arithmetic sequence, is given by a plus n minus 1 times d, where a is the first term of the sequence and d is the common difference for the sequence. Now, in this question, we are given Tn of an arithmetic sequence. So a has been included in this, of course, and so has d. So basically it comes from this here. If we knew what a and d were, we could plug them into this, leaving n as it is, so we just get a general formula for Tn. Now in part A we want to write out the first three terms in the sequence. Well, the first term is just T1. T1, as you know, is also called A. We just plug 1 in for n. So we have 38 minus 4, which is 34. So now we know that the first term is 34. I could even start to write out this sequence. This is A or T1. To get T2, we just plug 2 in for n. So we have 38 minus 8 is 30. Now, to get T3, we could again just plug 3 in for n. 38 minus 4 times 3, that's 38 minus 12, that's 26. Or we could have just worked it out from knowing the first two terms, because once you know the first two terms of an arithmetic sequence, you can find all subsequent terms. You can get the difference basically. You can see that the difference is the second term minus the first term, or any term minus the previous term, which is 34 minus 30, which is, sorry, it's not 34 minus 30, but it's 30 minus 34. So the difference is negative, it's minus 4. So knowing the difference, we can calculate the third term just by taking the second term and subtracting 4. You can see that it's quite straightforward. We just subtract 4 each time. So that's another way we could have got the third term. In the next question, we want to get the first negative term in this sequence. We want to find out what is the first negative term. Of course, we could just keep writing this out until we get to it. So I've written out several terms of this sequence. 26 minus 4 is 22, 22 minus 4 is 18, 18 minus 4 is 14, and so on. And I eventually get to a negative term. I get to minus 2. If we just count these terms, we'll see that T10 is equal to minus 2. So the 10th term is negative. 10th term is negative. We actually want the 10th term, so our answer is minus 2. So the first negative term in the sequence is minus 2. The second negative term in the sequence would be minus 6. In the next part, we have to find the sum of the first 15 terms of the sequence. Now you could write out 15 terms and simply sum them. I've most of them written out actually as far as the 11th term. The 12th term would be minus 10. The 13th term would be minus 14, and so on. 15th would be minus 18, and anyway, I won't do it that way. We could just sum all the numbers. What I will do is use a formula for Sn, which I derived in the previous video. And I explained, I did one example in the previous video. So what do we need? We need the sum of the first 15 terms. Well, that's just S15. So 15 goes in for n. We need a, which is the first term. First term is 34. 15 minus 1 here. What's the difference? Well, I showed that to you already. The difference is any term minus the previous term. So to say the second term minus the previous term, 30 minus 34 is minus 4. So the difference is negative here. In here we get 2 times 34 is 68, plus 14 times minus 4 is minus 56. So we get 68 plus minus 56, or 68 minus 56, which is 12. And 15 divided by 2 is 7.5. 7.5 times 12 is 90. In part D, we want to find the value of n for which the sum of the first n terms of the sequence is 0. So in other words, we want to put Sn equal to 0. So we want to put this here equal to 0 and find n. So let's do that. So we have n over 2 into 2 times a. Well, 2 times a is 68. 2 times 34 is 68. Plus n minus 1 times d, which is minus 4. And we set this equal to 0. So we need to work backwards here to find out what n is. We can simplify what's inside the square brackets. We have 68, and then we have minus 4 by plus n is minus 4n. Minus 4 times minus 1 is plus 4. Then we can add the 68 onto the 4 to get plus 72. Now we have a product of two things here, two expressions equaling 0. So the only way that can happen is if one of these is 0. So either n over 2 is 0, which would mean that n would have to equal 0, because 2 times 0 is 0. 0 divided by 2 is 0. Now that's not a solution. That doesn't make any sense, so we ignore that one. But it's an option. It will actually solve this equation. And the other option is to put this equal to 0. Because if this thing is 0, then we'll have 0 times n over 2 is 0. So when you see a product of two things giving 0, then it means that either of them is 0. It's only true, of course, if we've 0 on the right hand side. It's not true if we have any other number. The only way to get 0 is if one of these factors is 0. So if we put the second factor equal to 0, we get minus 4n equals minus 72, or n equals 72 divided by 4. That's 4 into 7 goes once, and 3 over 4 eighths are 32. So basically it means that S18 equals 0. So n equals 18 is the answer to this question. So if we were to take 18 terms of our series and add them together, we get 0. I've written out the first 18 terms of our sequence. The 18th term, T18, is actually minus 34. And if we were to sum all these terms, we get 0. So we've a good few positive terms, but all the negative terms would cause everything to collapse down to 0 if we were to sum all these terms. So this is another way you could have done this question. You could have just kept adding on terms until you got 0. So if you were to add all these together, just leave out the commas. So on, you just leave out these commas and just put all these terms together, you would get 0. In an arithmetic series, the first term is 6 and the fifth term is 22. So I've written down the first term, which is also called T1, or A, and I've written down the fifth term, T5. So there, we have T2, T3, and T4. We have 3 terms in here. And we're interested in finding this series. So how could we do it? Well, one way we could do it is to write down Tn, the nth term of any arithmetic series. We know what A is. A is equal to 6. We don't know what D is. In question 1 we have to find D. However, we do know that T5 is 22. T5 is equal to 22, and we can use our formula. A is 6 plus n, which is 5, times d, which we don't know, and this has to work out to 22. So we can just solve this equation to find d. So here we have 4d. We bring the 6 over. 22 minus 6 is 16. 16 divided by 4 is 4. So D is 4. So that's the answer to part 1. And knowing what D is, we can actually write out our series. 6 plus D, 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 4 is 18. 18 plus 4 is 22. So it's all checking out. Of course, we probably could have worked this out here without knowing anything about this formula. It shouldn't take too long to figure out what these three terms have to be if the fifth term must be 22 and the first term is 6. In part 2 we want to find T14, or the 14th term. Well, we could just write out these terms until we get to the 14th one. Or we can use our formula, which is a plus n minus 1d. So a is 6, n will be 14. Okay, this is the formula for Tn, where n is 14. D, the difference, is actually 4. So we have 14 minus 1 is 13. 13 times 4 is 52. We have 52 plus 6, which is 58. So T14, the 14 term is 58, so that's somewhere along here, over here somewhere. In part 3 we want to find S20, the sum of the first 20 terms. This is just a straightforward question. We plug 20 in for n and 6 in for a, 4 in for d. So this is our formula Sn, which I derived in the first video, and we get S20 equals 880. The sum of the first n terms of an arithmetic series is given by S sub n equals n squared minus 16n. Use S1 and S2 to find the first term and the common difference. We know from the first video that Sn, the sum of the first n terms of an arithmetic series, is given by n over 2 into 2a plus n minus 1d. Now, we don't know what a is and we don't know what d is. If they were known and we plugged in for a and d, we'd get an expression in n. If we plug in numbers for a and d and simplify down, we would get this expression here, n squared minus 16n. The n squared comes from multiplying n by this n here. This n over 2 is multiplied into this. This would just be a number. D is just a number. So we get a quadratic expression if we knew what a and d were, and it would simplify down to n squared minus 16n. Now if we want to reverse this to find out what a and d are, we need to note a very important fact about an arithmetic series, or any series for that matter, and that is that S1 is the same as the first term T1. But T1 is also known as A. Now S1 is the sum of the first term. You can't even say it. It doesn't make sense because you're not actually summing anything. But it has to give you the first term. So if we just plug 1 in for n in this expression, we get 1 squared minus 16 times 1. This is 1 minus 16, or minus 15. So this is the first term, or A. Now, how are we going to find D? Well, we first of all find S2. That's the sum of the first two terms. And to do that, we use this expression here, of course, that we're given. So S2 is 2 squared minus 16 times 2. That's 4 minus 32, or minus 28. Now this is S2. This is the sum of the first two terms. So we note a very important fact. S2 is just T1 plus T2. Knowing this fact, we can find out what T2 is. We can find the second term. And if we know the second term, we can find D, the difference, because D is just T2 minus T1, the second term minus the first term. So minus 28 equals T1, well, T1 is A, which we worked out to be minus 15, just the same as S1 actually, plus T2. So we can solve this for T2. So we get minus 28 plus 15. T2 is minus 13. So now we can start to write down this series. The first term T1 is minus 15. The second term T2 is minus 13. I'll write it down as a series now, so I won't put in the commas. When you see the commas, we refer to it as a sequence. Without the commas, we refer to it as a series. And straight away you can see what D is. The next term you can see must be minus 11. That's T3. Minus 15, minus 13, minus 11, minus 9, and so on. So the answer to question 1 is A is minus 15, but D is got by taking any term, say the second term, and subtracting the first term. T2 minus T1. So we've minus 13 minus minus 15. That gives plus 2. So D is positive. So we just add 2 onto any term to get the next term, and so on. Minus 13 plus 2 is minus 11. Minus 11 plus 2 is minus 9. Minus 9 plus 2 is minus 7. Minus 7 plus 2 is minus 5. Then we have minus 3, minus 1. Minus 1 plus 2 is plus 1. Then plus 3. 3 plus 2 is 5. 5 plus 2 is 7, and so on. In part 2, we have to find Tn, the nth term of the series. Well, we know for an arithmetic series or sequence, the nth term is a plus n minus 1 times d. Okay, I derived that in the first video. So what we want is an expression for Tn, where n is any number. So we just fill in for a and d. Well, a is minus 15, and d is plus 2. We just simplify this. We will have a minus 15 here and a minus 2 when we multiply. So we'll have minus 15 minus 2 is minus 17. And then we have 2 times n. Minus 17 plus 2n. Or 2n minus 17. Might look better to write it this way, but it doesn't matter. So there's an expression or formula for Tn. I want to just check this formula quickly. I'll calculate T1. T1 is 2 times 1, which is 2, minus 17. 2 minus 17 is minus 15. That is indeed the first term. Of course, this is not 100% guaranteed, but it's quite likely to be true. If it's true for one of these values, it's probably true for all of them. In the next part of the question, we want to find the values of n. N is, of course, a natural number. Capital N just means a natural number. It's one of the positive counting numbers, or integers, for which S sub n, the sum of the first n terms, is minus 63. Well, I've written out the series here. So we want to find out how many terms do we need to take so that the sum is minus 63. Well, we could do that by just inspecting the series. Or we could also solve an equation. So we could just start putting terms of the series into your calculator and keep combining them until you get minus 63. So we have minus 15, minus 13, then we have minus 11, then we have minus 9, then we have minus 7, minus 5, then minus 3, and actually if we sum as far as minus 3, we will get minus 63. So this sum here is minus 63. And how many terms is that? 1, 2, 3, 4, 5, 6, 7. So S7 equals minus 63. So I found one solution, n equals 7. That's one solution, but that's not. To find another solution to this equation here, we just keep adding on more terms. And actually that's quite straightforward to do for this series here. If we just add on the next two terms onto S7, just add these two terms on, we will still get an answer of minus 63, because minus 1 plus 1 is 0. See, these cancel out. So if we're adding two terms onto S7, then we're looking at S9. So S9 is also minus 63. So the other solution is n equals 9. So n equals 7 and n equals 9 are the two solutions of this equation. Of course, the other way to do this problem is to start with this equation and solve it. We put it equal to minus 63 and we plug in for a and d. If we plug in for a and d, we'll get n squared minus 16n. How do I know that? Because it's given to us. So we don't even have to go plugging in here for a and d. We could, of course, and if we broke it down we get this. So basically we need to solve this equation here. Now this is a quadratic equation. It's got n squared in it. So we could write it in standard form, n squared minus 16n plus 63 equals 0. We could try and factorize this. It's a quadratic equation. It has two linear factors. The factors of plus 63 are minus 7 times minus 9 gives plus 63. And you can check that these are indeed the correct factors of this. You can check that if you multiply these terms together, you get minus 7 minus 9 is minus 16n. You will get the term in the middle. Of course, now the product of the factors is 0. The only way a product of two terms or numbers or expressions can be 0 is if either of them is 0. From this we get n equals 7 and we get n equals 9 as you've seen before.